Okay, so welcome everyone to the first session of the day in the waterfall room. I'm very excited to introduce you to this session, which is exploring Strimzi's implementation of rolling updates with Tina Selenge. So with that, Tina, I'm going to hand over to you.
Thank you, Kate. Hi, everyone. Thank you so much for joining the session. My name is Gantigmaa Selenge, but I go by Tina. I work on Red Hat MQ Streams, which is a data streaming platform based on Apache Kafka. So as part of my role, I work on Strimzi as well. So in the past year, I worked on Strimzi's rolling updates. I spent quite some time working on that. So in this session, I'm excited to share what I've learned. Right. So here's an overview of cluster operator and Kafka cluster it manages. Kafka cluster is typically deployed with 3 or more broker nodes. And if you're running in craft mode, you typically also have 3 or more controller nodes. As you know, the operator deploys and manages all the resource needed for your Kafka cluster. And that includes the rolling update for your Kafka cluster as well. So when you're doing rolling update for your Kafka cluster, it has to be done really carefully to avoid any impact on the cluster availability and client applications. It can't be just left to Kubernetes, even though it does have a rolling restart feature, because Kubernetes doesn't have the Kafka-specific knowledge that it needs. So this brings us to KafkaRoller, which is a component, internal component of Strimzi that is responsible for coordinating the rolling restart for Kafka cluster. It uses various sources to get information about Kafka cluster to perform the updates with as minimal disruption as possible. So in this session, we're going to deep dive into KafkaRoller component. We'll be looking at what triggers rolling update and how KafkaRoller makes decisions whether to restart the pod or not, and what kind of safety checks it does perform before restarting the pod to ensure minimal impact on the cluster, and what happens after rolling restarts, like what sort of outcomes we expect. And also KafkaRoller is a very complex component. It works really well. However, it's not perfect. There are still things we could improve with it. So we'll look at some of the shortcomings of it as well. So Strimzi has a periodic reconciliation, it gets triggered every 2 minutes by default. And this interval can be reconfigured using the Strimzi environment variable. Reconciliation not only gets triggered by the timer, but there are certain events that trigger the reconciliation as well. And KafkaRoller runs as part of this reconciliation process. So this is from high level how KafkaRoller works. The first thing it does is order pods. The restarting the pods in the right order is quite important. There are different nodes with different roles and responsibilities. So which one you start first or last has different kind of impact. It then repeats the process of determining the action for a pod and doing the safety checks and going ahead and taking the action. So these 3 steps are repeated process, which gets executed for each of the pods in the order. Another thing that KafkaRoller does is try recovering any unhealthy pods, which could result taking the action immediately without doing the safety checks. So we'll take a look at those scenarios as well later. And if the action fails for the pod, we might have to repeat this process again for that pod as well. So again, this could be repeated for each pod multiple times. And then at the end, we'll complete the reconciliation with either success or failed result. Okay, so let's walk through each of these steps. Let's have a look how KafkaRoller orders the pod. So KafkaRoller always attempts to restart the unready pods first, because like I said, it tries to recover the unhealthy pods first. before doing anything else with it. We also don't want to restart any of the healthy pods in case they break as well. So this is why we do them first. And in Craft, we also restart the controller pods first, because without the quorum, brokers would not be able to operate correctly. And it's quite important that we operate in the quorum controller nodes first, make sure the quorum is healthy and stable before we do anything with the brokers. So first we put the unready controller pods, and then after that we put the controller pods. And the one of the controller pod will be the active controller or the quorum leader. And restarting the active controller is potentially a destructive event, because that would mean the brokers would need to reconnect and the new active controller need to be re-elected. So this is why we want to do this at last. So we put the active controller at last of the controller nodes. And then we put the unready broker pods, and then the broker pods. And if you're running in Zookeeper mode, one of these broker is also the controller. So again, that controller would be put to be restarted at last. Okay, so when I say unready, ready, what does it really mean? So this is basically Kubernetes readiness check, which is based on the broker state. So when Kafka node starts up, it transitions through different kind of states, and it emits that state as a metric, which is called broker state. And if the broker state is equal or greater than running, that means this broker is ready. It just means it's ready to serve requests. And it applies to both Zookeeper and Craft-based broker. And in Craft mode, you can also have a node that is both controller and a broker, which we call a mixed node or combined node. And this check also applies to mixed node as well. And then we also collect the broker state metrics and expose that by using Kafka agent, which is a Java agent that we run with the Kafka nodes. And for Craft controllers, we have a different readiness check. So the controller pod is considered to be ready if the controller process is listening on the part defined in controller listener names configuration. So this is the part that brokers use to communicate with the quorum. Okay, so let's take a look at how we determine the action for a pod. As I said earlier, we always deal with the unready pods first to recover any of the unhealthy pods. So there are various different scenarios why pods might be unready. So we'll look at those different scenarios and see that what kind of decision KafkaRoller makes with it. So first, the KafkaRoller checks if the pod has been in unresolvable state for some time. And this is indicated by one of these Kubernetes pod status or container state. So if the pod is in any of these states, it considers it to be stuck. So let's see the flow, what we do with that. So we check if the pod is stuck or not. And if it's not stuck, we're just gonna give it a chance to become ready. So we'll just do some waiting. And this wait has a timeout. We'll talk about that more later. And this is just to give the chance, give chance to the pod to become ready in case it was just started. It might just need a bit more time to start serving before it starts serving requests. And if it is stuck, the next thing it checks is if this pod is out of date, meaning that if this pod is running with the desired version, desired configuration, is there any like pending update to be applied to this pod? And if it's not out of date, so it is running with the latest, the desired version, then we're going to immediately fail the reconciliation here. This is because there's no really point of restarting this pod, because when it gets restarted, it's probably going to end up in the same state. And we also want to avoid restarting other pods as well, in case they also end up in that broken state. So this is why we fail the reconciliation. And then if it is out of date, if there's any pending updates, then we're gonna go ahead and immediately restart the pod. So this is because, for example, if the pod was stuck because because you misconfigured the node affinity, for example, and now you fixed the configuration, so you want this pod to be restarted with the right configuration now. So next up, pod performing log recovery. So we said we'll give the pod a chance to become ready by doing some wait, and after that we check if the pod's still not ready, and if it is still not ready, then we're gonna check the broker state and see if it's doing log recovery. So when broker starts up, and if it previously had unclean shutdown, the log recovery process gets triggered to make sure the log is in a good state, it's not in a corrupted state. So this is why it does that. So if it's not doing log recovery, there's nothing to do. So we're just going to continue with the rest of the process. But if it is doing log recovery, there's not much else KafkaRoller can do other than wait, because we don't want to restart this pod in case, when the read starts and it's going to do the log recovery again. And before it finishes, we might restart again. And we could end up in this loop. So what it would do is it would apply some delay and then retry this pod and wait again to see if it finished doing the log recovery until we reach the max attempt. So the max attempt is set to 10 in Strimzi. And if you do reach the max attempt, then we're going to fail the reconciliation immediately. So by failing the reconciliation, we also notify the human operator, because if the reconciliation keeps failing because of log recovery, the human operator might have to intervene and investigate what the problem is. And it's really hard to determine how long this log recovery might take. It might take minutes, it might take hours. So the log recovery progress gets logged in the operator. You would typically see this warning log message, which has the remaining logs and segments left to recover. So if you see these numbers decreasing, maybe just log recovery is taking longer than usual, or like just maybe slow, but is progressing, then you might just have to give it some time. However, if you don't see these numbers decreasing at all, then something might not be right with the logs or the disk, so you might have to go and investigate that. So the next thing is the pod unresponsive to connections. So this check is done actually for not just unready pods, but also for ready pods. So for any pod, we always check if we can connect to the pod or not. And we do that by initializing Kafka admin client. And if the connection is not successful, we need to restart this pod immediately. And this is because the potentially clients can't connect to this pod as well. So we need to try fix this as quickly as possible. But if we can connect, then great. We just continue with the rest of the process. So that was the various scenarios that why pod might be unready and what KafkaRoller does with it. For ready pods, we also need to determine if we need to restart the pod or not. So the main triggers for running restarts for ready pods, if the broker TLS certificate is renewed, so the Kafka nodes need to be restarted to start using the new certificate. And if the pod and Strimzi pod set is annotated with manual rolling update, so this is how the user triggers rolling update manually. And if there's any change in the Kafka custom resource detected, so this change can be, for example, Kafka configuration that cannot be updated dynamically. If it can be updated dynamically, KafkaRoller would just use the Kafka admin API to update the configuration. However, if that configuration update repeatedly fails, then as a last resort, we will also go ahead and restart the pod. And then maybe Kafka version has changed or container image is updated. So this is not the exhaustive list. There are various different changes in the Kafka custom resource that can trigger the rolling update. Right, so we determined the action, and next we need to do the we need to do the safety checks. There are two safety conditions, KafkaRoller checks. Availability check is for brokers and mixed nodes if you're running in Craft. So this ensures that the replication count of topic partition does not fall below the configured min in single replicas. This is really important because producer clients with Excel settings won't be able to produce anymore. And also consumer clients won't be able to commit offsets because it does that by producing to topic with Excel settings as well. And then we do also quorum health check for Craft controllers and also for mixed nodes. And this ensures that majority of the controller nodes are up and running and also have the up-to-date metadata. Okay, so let's take a look at some examples of availability check, what it does. So let's say I have 3 broker nodes, and broker 0 is the partition leader for my topic partition. And in here, broker 2, as you can see, is fallen behind, so it's not part of the ISR list anymore, so the in-sync replica list. So if I was to restart broker 1, that would mean the ISR count will fall below the configured min ISR of 2, so I can't restart broker 1 in this case. Again, if we were to restart broker 0, that cannot be done because broker 2 is fallen behind, the same thing. However, we can restart broker 2 because it's already not part of the ISR list, so it will not impact the replica count against the main ISR replica 2. And if my topic partition is replicated across all my brokers, then any of the broker can be restarted safely. Okay, so the Craft controller quorum. So the controller nodes form a quorum, and one of the controller nodes then becomes the quorum leader or the active controller. And all the brokers then connect to this active controller to update the metadata or retrieve the metadata. And then the other controller nodes just simply follow the active controller and tries to keep up to date with the metadata updates. And if the active controller was to go away, we need at least the majority of the other controller nodes to be able to maintain the quorum and also be able to elect a new leader. So one of them will become the leader, and then the brokers will reconnect to that. So let's take an example again. Let's say if I have 3 controller nodes and controller 0 is the active controller. And if we were to restart controller 1, we need to make sure controller 2 is up to date with the metadata topic. If it's fallen behind, then we won't be able to restart controller 1. If we were to restart active controller 0, then we need to make sure both controller 1 and 2 have up to date with the metadata topic. If any one of them has fallen behind, then we won't be able to restart active controller. Okay, so we took a look at the safety checks that we do, and next we're gonna go ahead and do the action. So the action of restarting the pod under the cover, we're just doing kubectl delete pod. We wait for the pod to be deleted, and then we wait for the new pod to become ready. And I also in the previous steps mentioned about waiting for the pod to become ready in case it was just restarted. So all of these waits have a timeout of 5 minutes by default, and this can be reconfigured using the Strimzi environment variable called operation timeout. So once we've done all the actions, then we will go ahead and complete the reconciliation. In these success scenario, obviously all of the pods would be restarted and all of them will be in a healthy, ready state. And in that case, the reconciliation will complete with successful result. But there are various scenarios that reconciliation will fail, as we saw some of it earlier. So there are some non-retriable failures will cause the reconciliation to fail immediately. So one is we cannot connect to Kubernetes API. Obviously, if we can't connect to Kubernetes API, there's not much we can do. We can't do anything with the pod. We can't check if the pod is ready or not, etc. And also we can't connect to Kafka agent to check the broker state metrics. As you saw earlier, that's quite important for checking the readiness of the broker, to see if it's doing log recovery, that kind of stuff. So it's really important that we have the connection to Kafka agent. And if the pod is stuck and does not have the old revision, meaning that it's running with the desired version and configuration, doesn't have any pending updates, then yeah, we're gonna go ahead and fail the reconciliation. And there are some retriable failures that will eventually fail the reconciliation if the maximum number of attempts reached. So that is if pod is not ready because it's doing log recovery. We saw that earlier. And if we can't connect to the pod using the admin client, and also the request to the admin API keeps failing. So as we saw earlier, that it's quite important to interact with the admin API and have the successful request, to get the Kafka configurations or to do the availability check, that kind of stuff. So it's quite important that we have this working. And if the pod never becomes ready. So we looked at various scenarios and logic that KafkaRoller has. Let's go through a quick example of a rolling update on a full cluster and see how that looks. So let's say I have a cluster of 6 nodes, and 3 of those nodes are controller nodes. And actually one of them is mixed node, meaning that it's both controller and the broker. And controller 2 is the active controller. And I have 3 broker nodes too, which highlighted in red are unready. So we're going to take a look at controller 0 first, and we find that pod is ready, can be connected, great. And we find that controller Strimzi pod set was annotated with manual rolling update. So that means all of the controller nodes would need to be restarted. So because it's controller node, we're going to do the quorum health check. If that's all good, then we're going to go ahead and restart. Okay, let's say we restarted Kafka controller 0 and it's ready. So we're going to move on to mixed 1. Again, exactly same steps as controller 0, except one different thing, which is the availability check. So because it's both controller and a broker, we also do the availability check before we restart. So if that's all good, then we go ahead and restart mixed 1. And then as last controller node, we check the active controller now. So again, exactly the same scenario, but when we're doing the quorum health check for this node, we need to make sure both mixed 1 and controller 0 are have the up-to-date metadata topic. Okay, so we have restarted all of the controller nodes because we restarted controller 2, which was the active controller. Now the active controller moved to controller 0. And then we're gonna next check broker 3, which is one of the unready pods. Okay, so pod is not ready, and we find that broker 3 is in a crash loop backoff. Then we go ahead and check if it has an old revision, and if it does, therefore we need to go ahead and restart it. And then broker 3 comes back ready and great. So then we move on to the next unready broker, which is broker 4. So this time pod is not ready, but it is not stuck. And so we're gonna just give it a chance to become ready in case it was just restarted. And we find that pod is doing a log recovery. So we're gonna just apply some delay and retry this pod later. On the second retry, the pod is now ready. However, we can't connect to this pod. Therefore, we're gonna just go ahead and restart this pod. Okay, the broker 4 then came back ready, so good. And then now, finally, we're gonna move on to broker 5. Broker 5 is ready and can be connected, great. And we find that configuration has changed for this broker. And this configuration cannot be updated dynamically. So we would need to restart this pod. And we do the availability check before we restart it. However, the broker 4 that was previously restarted hasn't caught up yet. That means that my topic partition would fall below the mean ISR configured min ISR API restart broker 5. Therefore, this availability check fails. And so we're going to just apply some delay and retry this later on. On the second retry, broker 5 is ready, can be connected again. And then we find the configuration has changed, the same thing. And we do the availability check again. And we find that broker 4 has caught up now. So it's joined the ISR list. So it's all good. And availability check passes. And we go ahead and restart this broker. Okay, so this is a successful scenario where we were able to restart all of the pods successfully and apply the updates. And in this case, reconciliation will be completed with success result. Okay, so let's take a look at the shortcomings of KafkaRoller. As I mentioned, it's a complex, as you can see, it's a complex component. It has a lot of nested loops and logics and different scenarios that it has to deal with. So one of the major shortcoming is that we restart one broker at a time. So it is the safest way of doing things, but that makes the rolling update really slow in large clusters. So if you had a cluster with 100 of brokers, the rolling update could take hours and hours, possibly. And even though we're doing this as minimal disruption as possible, it's still causing some level of disruption. And that means the longer the rolling update takes, your cluster will be in that vulnerable state longer as well. And the next thing is that the roller doesn't wait for partitions to be assigned back to the preferred leader after it gets restarted. And this can cause unnecessary amount of partition leader elections. And every time there's a new leader election, the clients will have to reconnect. So it is causing more disruption than necessary, basically. And the code for this component has grown really complex over the years. Obviously, Kafka has been changing, so KafkaRoller had to adapt to that. And it has become so complex and not easy to grow and not easy to add new functionality. And this was the pain point when we were introducing support for craft. And there are still some edge cases for craft that need to be addressed, and it is not easy to address with the current state of the code. And the code at the moment is not really testable. Therefore, we lack in test coverage, and we miss those edge cases because we're missing lack in test coverage. So that makes it even more difficult to refactor this component and make it better. So that brings us to KafkaRoller 2.0 that we're introducing. So this is a new roller, completely new roller component, and aims to have simplified logic and has structured design resembling a finite state machine. And the proposal for this new roller is under review at the moment. So if you would like to go and learn about it, please go and check out the proposal. And we aim to enable this new roller only for craft mode, so it wouldn't apply to the Zookeeper mode. And having simplified logic and better code, it will make it easier to add more changes later on as well. That's the aim, which is really important for craft because craft is still new for us. As we learn more about it, we might have to make more changes to the roller. So yeah. So when I say finite state machine, so what I mean is that basically the idea is for each node to have a state, and the roller collects then information from various sources and transition nodes state based on that information. And then it takes a specific actions based on the observed state, and these actions cause subsequent observations and then leading to state transitions. And this is an iterative process, ensuring alignment of each node with the desired state. So it's just from high level, there's more details in the proposal for this. So let's take a look at the main new features that KafkaRoller 2.0 is bringing. So one is being able to restart brokers in parallel when the safety conditions are not violated. So on top of the availability check that we already do, we also will make sure the brokers we're restarting together do not share partitions in common. So we, make sure the topic availability is not impacted. And user can define how many brokers they want to restart in parallel. This will be set to 1 by default, meaning by default you have the original behavior of restarting 1 broker at a time. And this only applies to broker nodes. So controller and the mix nodes will be restarted one at a time, because typically you wouldn't have as many controller nodes as the brokers. Also, it's safer to restart 1 controller at a time to have minimal impact on the quorum and the overall cluster stability. And then it's going to wait for the partitions to be assigned back to the preferred leaders before we do more restarts. And that way we cause less partition leader elections. And then because it's more simplified, we'll be able to solve those edge cases I mentioned for craft much easier with the new component. And the aim is also to make this component much more testable so that we can increase the test coverage. The last 2 is really development details. As a user, you wouldn't need to worry about these changes introduced to the code level. The main difference is really the ability to restart brokers at the same time and triggering less preferred leader elections. Everything else remains the same, so don't worry. What we just learned in this session is still going to be useful. What we just covered is for the KafkaRoller still apply to the new roller. And this actually nicely summarizes what we learned in this session. And yeah, that brings me to the end. Thank you so much for listening. And yeah, I'll open up for questions.
Thank you so much, Tina. That's very interesting, definitely. And we have quite a few different Q&As. So the top one that's been voted is this process completely separate from the drain cleaner, or is there any crossover between KafkaRoller and drain cleaner?
I believe it's completely separate. Yeah. I haven't worked on drain cleaner myself too much, so I haven't come across it. That means I think it's completely separate, yeah.
Yeah, I can actually add to that because I have played around with drain cleaner. So drain cleaner is focused on moving pods from nodes and making sure that it's safe to do that. But yeah, although I guess they potentially could have had some logic in common, they are completely separate components within Strimzi. So the next one we've got is, why do you restart controller pods first? Wouldn't the old controllers work with the newer regular brokers and it would be safer to do things like that?
Yeah, so the reason for that was, as we saw, like we tried to recover the unhealthy nodes first. And if there was something wrong with the controller nodes, it's important that we go and fix the controller nodes first, because then we don't want to restart broker nodes in that and then cause more chaos. And from my experience, if the quorum is broken or something is not right with the controller nodes, brokers go into really strange state. And yeah, so that was the main reason.
And then the next one we've got is, could you make the waiting time between rolling different pods configurable so that I could introduce artificially longer delays, like, for example, only rolling 1 pod every 10 minutes?
I guess you can play around with the operation timeout and the reconciliation interval. So those are the 2 configurable values you can play around to make that happen, I think.
It looks like somebody's commented who I guess has looked at drain cleaner, says apparently drain cleaner does invoke the manual rolling update via the annotation. So that will then hand off to the KafkaRoller.
Yeah, there are different reconcilers, not just the Kafka reconciler. There are different reconcilers within Strimzi that might go and do the use the manual rolling annotation to kick off the rolling update. So that will be the crossover.
And then I think those are all the questions. There was one that was asked about, wouldn't it be better to wait for the preferred leader election? But obviously that's something that isn't done currently, but is coming in KafkaRoller version 2. But yeah, if anyone has any other questions that you can think of, then feel free to post them there. But for now, I'll stop the broadcast and the recording. So yeah, thank you again, Tina, for a lovely session. And we'll be back at...
Can I just mention one more thing?
Yeah, go ahead.
And if you came across any other pain points with the current roller, it can be part of the new roller and improve that situation. And you can bring that up in the proposal discussion as well. So that'd be really useful for us as well.
Yeah, definitely. Oh, the other thing I was going to ask actually was, I believe there's a proof of concept for the new KafkaRoller, right? So people could go and have a look at what the code might look like if they were interested.
Yes, that's right. Yeah, we have the proof of concept already written. So once the proposal is accepted, that would be the code that you used for the real implementation.
Awesome. Okay, just check we haven't had any more questions come in. Can't see any. Cool. So yeah, we'll be back. So the next session is going to start at 3:50 in GMT +2. And that's going to be modernizing Nubank's Kafka platform for the next 10 years, starting at 1 trillion messages per month. So we'll see you for that.
Thanks, everyone. Bye.